Okay, question 6. We've got our skills now for solving our linear equations when they had numbers galore and maybe one little letter. Now we've got a few in here, so we've got M, M, M all over the place. I know we said before in a previous one that when you've got just a 1 here, you probably want to put that as your first. It's a gamble. It's up to you. That's got an M in it as well, so I'm just going to leave the first row as it is, even though it's got a 2 as the leading coefficient there. I'm just going to keep that there and treat it normally. So here we go. We go 2, 1, minus 1 for those who like to be nice and neat. Notice I'm spacing things out a little bit. You'll see why soon. Now what we want is a 0 there and a 0 here. So we're going to multiply the first row by M, and we're going to multiply the second one by 2 and subtract. And for getting a 0 in the third row, it's going to be our row 1 minus 2, row 3. Okay, I'll do that to the start. I'll stop the video. You do it as well. Okay, just check yours with mine. Just multiplied the top row by M. That's this one. And multiply the second one by 2. So now we're going to subtract. 2m take 2m is no m. M take is a plus. And we've got minus m take 2 and 3m take 2. Okay, so that goes over here, and you can see why we've left a bit of room so we're not too squashy. Again, you want to try and read your work really clearly, so it's all about the neatness. Okay, check that one is correct as well. 1 take 4 is minus 3, minus 1 take 2m is minus 1 take 2m, and 3 take 2 becomes plus 5. Right, so we've got minus 3 here, we've got minus 1 take 2m, and 5 going along swimmingly. This is now, it really starts to get interesting, and you have to be even more careful, because what we want now is the 0. Oops, don't want that. Okay, so we want the 0 here now. So what we're going to have to do, and this is where it gets hairy McClary, we are going to multiply this row by the 3. And we're going to multiply this one by m plus 4. All right, so you can multiply it by 3 or minus 3. Let's just go with minus 3 since we're sticking with the same thing. And then we're going to subtract m plus 4 times row 3. Okay, so down the bottom here, we're going to times that. So it's minus 3m take 12, 3m plus 6 minus 9m plus 6, and then we're multiplying the bottom row by m plus 4, so this becomes minus 3m take 12. Now this one we're going to be multiplying minus 1 take 2m by m plus 4, so that gives me minus 2m squared. What have I got? Minus m take another 8m, so minus 9m and minus 4. If I times that by 5, then it's 5m plus 20. I'm going to subtract, they all disappear. Okay, that's 0, that's what we wanted. Now here, 0 take 2m, we've got, that makes 2m squared. If you're not quite sure what's going on there, we're writing this, we're going 3m plus 6 minus 2m squared take 9m take 4. So if you don't want to do it all in your head, write it out. So plus 2m squared, 3m take 9 becomes 12m, and 6 take 4 becomes plus 10. Down here, minus 9m take 5m is minus 14m, and 6 take 20 is minus 14. Now, before I pop that into my matrix, I'm going to simplify this so I can see everything's got a common factor. So that becomes m squared plus 6m plus 5. This has got a common factor of minus 14. So pull that out, and I can go even further with this because I can factorize this quadratic to be m plus 5, m plus 1. And that's what I'm going to put in over here. So it's going to be 2 m plus 5 m plus 1 minus 14. Now, if you sort of think, oh my God, I'm never going to get this in a test, or there's so many ways that I can stuff up, this is one of those questions where it would be, show that it equals this. So if you do happen to stuff up and you can't find your error, leave it after 2 minutes and go on and just take it from here. Okay? So once we're in this situation, we can see a couple of things start to be quite clear, I hope. And that is that when we look at this, we've got the same factor on either side of our equal sign slash the dotted lines there. And so when m is equal to minus 1, what's going to happen to that bottom row? What's going to happen is that we are going to have 0, 0, right? Minus 1 plus 1 is 0. 0 times anything is 0. And minus 1 plus, you get 0 there. So we have all zeros on the bottom line, which could be infinitely many solutions, but you have to now go back and check and look at the equations. So when m is minus 1, what are our equations? Okay, so when m is minus 1, let's go back up. What is our... So what do we get when m is minus 1? The first equation doesn't change. That's still the 2x plus y take z equals 3. Then we get minus x take 2y, because m is minus 1, remember. And then we get x plus 2y take z equals minus 1. Now, comparing the pair, if we look at these, they're basically the same. It's just that we've got this one times by negative 1. So what we're looking at here are two coincident planes. All right, and then we've got the second plane here. So they would intersect at a line. So if we pop that back into our equation, into our augmented matrix, we get 2, 1, minus 1, 3. Okay, 0 when m is minus 1 plus 4, it's 3 minus 1 take 2 is minus 1. Minus 3 take 2 is minus 5, and this is 0, 0, 0, 0. And notice that one is a negative 1, so we could, just to make our life easier, say let z equal, sorry, not z, we would let y equal t, right? So therefore, if I want z, I'm going to pop that over the other side, and that's going to be z equals 3y plus 5. So z equals 3t plus 5, and then you can pop that back in into the original one, to this first one, to find x. Okay, and just when you think, oh, it's all done and dusted, no, 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 because now we have to go, okay, what if k isn't minus 1, right? And it equals minus 5. So what happens then on the bottom line? We get 0, 0, right? 0, 0. But then we get a 0 here. And then when m is minus 5 plus 4, sorry, minus 5 plus 1 is minus 4 times 14. That is some kind of number, right? I don't even want to work it out. Let's go. I'm just putting, it's a number, okay? And so we've got the situation where it's 0z equals something. Let's imagine it's 10. And that's impossible. 10 divided by 0, no go. So for this case, we go no solution, right? Go back and look at your answers, or the question. I think this is part A and this one would be part B. God knows. Go back and have a look. But guess what? You're still not finished, because we've got another situation. And sorry, when I said K here, I did mean M. Hope you got that, right? When m, what if m doesn't equal minus 1 and it doesn't equal minus 5? That means we're going to have 0, 0. We'll have some kind of number here, and we'll have some kind of number there. So that means we're going to have a unique solution, right? And if we take z, we've got, have I got any more room here? Oh, yay. Right, so if we look at our bottom line here, it's going to be 2m plus 5, 2m plus 5, m plus 1, z equals minus 14, m plus 1. Okay, now therefore z will be minus 14 m plus 1 all over 2 m plus 5 m plus 1. Getting a bit excited, my writing's getting messier there. And what can happen is they will cancel. Now remember, we're okay, this cannot be, the bottom cannot be 0 because we've already established that they're not equal to each other. So we get z equals, we can cancel that, minus 7 over m plus 5. And I know it feels like you've done a bucket load of work, but alas, you now have to go back and pop it into the second row, right, to try and find an expression for y and then find one for x. And I'm going to be a bit mean and leave that for you to do. So 3y take z equals minus 5. Let's pop that, I don't know where it's gone, 3y, I think it's up here. So 3y take z equals minus 5. So 3y equals 5 plus z. So it's 5 take 7 over m plus 5. Right, and you have to try and get y by itself. So yeah, good luck with that. Okay, I'll do it for you. Okay, so just realized I used the wrong equation there. You actually have to go back up. All right, all the way back up to here. Yowza. Okay, so we got this from our second equation. Not very pleasant. I've substituted my z value in here, and notice I've pulled out a common factor of minus 1, just so I've got the positive. Okay, now we don't like this divide by m plus 5, so I'm going to times every term through by the m plus 5. So this becomes m plus 4 times m plus 5y. Now a negative times a negative gives me back my positive. And I've times that by the m plus 5, so that one now cancels out. So I've got 7 m plus 2. And don't forget, we have to times everything by that m plus 5. And we've got this. All right. Not great, but it's, just simple expanding and factorizing from henceforth. Now I'm not going to expand this because it's already factorized, and I want to end up getting y by itself. I'm really hoping that the other side will factorize nicely. But you can see the other side is 3m take 2, m plus 2, and then we're taking the 7m plus 2. I was really hoping, I was really hoping that there would be a common factor of m plus 2, and that's why I wrote m plus 2 where I shouldn't have. So normally I'd look to see if there was a common factor here or here, but alas there's not, so I have to expand. But we should be pretty good at that by now. Years and years of practice. Oops, what happened there? 3m. Alright, so we've got 3m squared plus 15 take 2, so plus 13m minus 10 minus 7m take 14. We end up with m plus 4, m plus 5. All right, 3m squared, 13 take 7, 6 take 24. Oh, would you look at that? That's a common factor of 3. M squared plus 2m take 8. And the love just keeps going. Our luck, because we can factorize that. M plus 4, m take 2. We do a little happy dance because when we look at what's on the left-hand side, we've got factors galore here. So when I now try and get y by itself, it's 3 m plus 4 m take 2 divided by m plus 4 m plus 5. Now we have to make a little bit of a statement here because we already had that m couldn't equal minus 5, so we're safe that that won't make the denominator 0. However, we're also going to have to consider our m, I mean, they cancel as well, but, you know, if it's minus 4, we're dividing by 0, but they're going to disappear anyway. So we end up with y equals 3 m take 2 over m plus 5. And you guessed it, you have to now put this back into the original one, right? And don't do what I did last time and put it into the wrong one. You have to go right back up, okay, over here, put it back here. But as you can see, we haven't got all the m's and whatever. It's just a nice sort of one there. That'll be a lot nicer for you. Pop that back in. You've got your z over here. You've got your y over here, so pop that back into the first one and find your x. I will leave that for you to do to give you some satisfaction. Good luck.